Hello friends, today we are discussing the subject microprocessor unit 6 interrupt table and more about it. The interrupt table, step in executing the interrupt, what are the sources of the interrupt, enabling and disabling the interrupts and priority of the interrupt. Today's discussion points are these ones. We will discuss it. It belongs to the unit number 6. Interrupt table. It defines whether a code of particular interrupt exception routine is located in the microcontroller memory. Interrupt vector table defines whether the code of the particular interrupt or exception routine which is located in the microcontroller or a processor memory. The interrupt vector table stores in a flash or a code memory. The interrupt vector table which is stored in a code memory or the flash memory of the processor. Interrupt vector table stores at the starting address of the code memory. Interrupt vector table IVT stores at the starting address of the code memory. A figure below shows the interrupt vector table along with their memory addresses and a memory content. Each memory address contains the address of an exception handler. Here, some of the interrupt vectors tables IRQ are shown here. Initial stack pointer value, then it reset, NMI, hard fault, memory management. All these are the IRQ numbers and the exception numbers which are from 1 to the 16 plus n. Some of this IRQ0, IRQ1, IRQ2, which are the with having the offset values, which shows the each memory address contain the address of the exception handler. Each memory address contains the address for the exception handler or the memory. What is the interrupt vector table? When an interrupt occur or when we say a interrupt X occur, the interrupt request will send to the nested vector interrupt vector. So whenever the interrupt is occur, a request will be sent to the nested vector interrupt controller. Next step of the NVIC to find the starting address of the interrupt service routine. That is the ISR. Whenever the interrupt is occur, a nested vector interrupt request will be sent. Then the next step is to find out the ISR or a exception handler to find out the address of the ISR. The starting address of the respective ISR or a exception handler is stored inside the interrupt vector table. The starting address of the respective ISR or exception handler is stored inside the interrupt vector table. Then NVIC uses the exception number X to calculate the address of the exception by looking up the IVT, by looking in the interrupt vector table and uses the content of that memory addresses to execute the exception handler. The program counter will be loaded with an address of the exception handler and the microcontroller starts to execute the exception routine. The NVIC uses the exception number X to calculate the address of the exception by looking up the IVT and use the content of that memory address to execute the exception handler. The program counter will be loaded with the address of the exception handler and the microcontroller starts to execute the exception routine. Step in executing the interrupts. The microcontroller closes the currently executing instructions and saves the address of the next instruction on the stack. It saves the current status of all the interrupts externally. It saves the current status of all the interrupts internally. It jumps to the memory location of the interrupt vector table that holds the address of the interrupt service routine. The microcontroller closes the currently executing instructions and saves the address of the next instruction on a stack. It gets the ISR interrupt service routine from the interrupt vector table and jumps to it. It starts executing the interrupt service routine with a RETI return from the interrupt request. Upon executing the RETI instruction, the microcontroller or the processor return to the location where it was interrupted. First, it gets the program counter address from the stack by popping the top bytes of the stack into the PC. then it starts to execute from that address. The processor has a 14 interrupt sources. When xxIF is an interrupt flag, then xxIE is an interrupt enable bit. As this is an example that a 14 IF is an interrupt flag, then a 14 IE is an interrupt enable bit. Interrupt flag shows the result of an interrupt flag shows the result of an interrupt, and interrupt enable bit is used to enable or to block the interrupt. Global interrupt enable bit GIE. When the GIE is equal to 1, it will enabling the interrupts, and if the GIE is equal to 0, it will blocking all the interrupts. As shown in a figure, interrupts with the lower priority, interrupts with the higher priority, and wake up if the sleep is more. So this is the sources of the interrupts. As shown in a figure, as IF and IE, two are shown are here. Whenever now we will see the enabling and the disabling of the interrupts. Whenever the interrupt is hooked, the processor to suspend the execution of the program and start the execution of the another. That means a processor has to stop the execution of the current process and start the execution of the new process. Interrupts can arrive at any time. They may alter the sequence of events from the ideas of the programmer. Hence, the interruptions of a program executions must be carefully controlled. When a device activates the interrupt request signal, it keeps this signal activated until it knows that the processor has accepted its request. This means that the interrupt request signal will be active during the execution of the interrupt service routine. Whenever the device activates the interrupt request signal, it keeps the signal activated until it knows that a processor has accepted its request. Whenever a device activate the interrupt request signal, it goes on this interrupt request signal till it the device come to know that a processor accepted its request. This means that an interrupt request signal will active during the execution of the interrupt service routine. Okay, this means that a ISR interrupt request signal will be active during the execution of the ISR interrupt service routine. The first possibility is that the processor ignore the interrupt request line until the execution of the first instruction of ISR has to be completed. The second option, the processor automatically disables interrupts before starting the execution of the ISR. The third option, the processor has a special interrupt request line for which the interrupt handling circuit responds only to the leading edge of the signal. Such a line is said to be edge trigger. Priority interrupts means what is the priority interrupt is a system which decides the priority at which various devices which generates the interrupt signal at the same time will be serviced by the microcontroller. When two or more devices interrupts the microcontroller or a processor simultaneously, it services the device with the highest priority. Whenever two interrupts are raised, so there must be a question of the priority comes. So interrupt having a highest priority get the processor services first. Daisy chaining priority. In the daisy chaining system, all the devices are connected in a serial form. The interrupt request is common to all the devices. If any device has the interrupt signal in a low level state, then the interrupt line goes to low level state and enable the interrupt input. When there is a no interrupt, the interrupt line stays in a high level state. The microcontroller responds to the interrupt by enabling the interrupt acknowledgement. If any device has an interrupt signal in a low level state, then the interrupt line goes to low level state and enabling the interrupt inputs. Decisioning as shown in a figure, as if a number of devices are connected, okay, it goes to the microcontroller through the PIR or P0 lines, interrupt request lines. Okay, so thank you friends for watching the video.